This is part 2 of a review of polynomial functions. This is AP Precalculus topic 1.1 through 1.6. If you haven't seen the previous video yet, you should probably watch that first. I will try to put a link in the upper right hand corner, or you can find a link in the description. If you appreciate this content, please don't forget to hit the like button. Number 10. The graph of the polynomial function k is shown above. Write a possible equation of least degree for the function k. Let's keep track of facts we know about the polynomial we will have to write. Because the right end behavior is approaching positive infinity, that tells us that we need a positive leading coefficient. So file that away. Because the end behavior is the same on the left and the right, that tells us that it has to be even degree. So we need a positive leading coefficient and we need even degree. Now let's look at the real zeros that we can see by looking at the graph. We see that we have a 0 at -4. So that tells us that we're going to have x plus 4 is going to be a factor. Also, when the graph is tangent to the x-axis, when you see a bounce like this, it has to have an even multiplicity. So this has to be at least x plus 4 squared. When I look at the real 0 of x equals -1, that tells me we're going to have a factor of x plus 1. At x equals -1, the graph just goes straight through. That happens when you have a multiplicity of 1, so I'm going to leave that just like that. And the same thing happens over here at a real 0 of 2, which tells me I will have a factor of x minus 2. The graph just goes straight through there, so that's going to be a multiplicity of 1 as well. So let's see what we have so far. We wanted a positive leading coefficient. So if I just leave this the way it is, it's going to be a positive leading coefficient. If I needed a negative, I would just put a negative in the front. So now I just need to check the degree to see if I already have an even degree happening. And just ignoring the constants, I see I have x squared times x times x. That's a degree of x to the 4th power, so I do have even degree. So in other words, we are good to go. So kabam, k of x, there you go. Number 11, the graph of the polynomial function p is shown above. Which of the following could be an expression for p? We have all these options here. I'm noticing that all of the options have a real 0 at x equals -3 and x equals +2, looking at these two factors. And they all have multiplicity 1. Okay, so I see the real 0 of -3 right here, a real 0 of 2 right here. This graph has a third 0 at 0. So that means A cannot be the answer because this one doesn't include an extra 0 at 0. The remaining 3 options all do have an extra factor that will give us a 0. Let's use the leading coefficient to eliminate another option or two. I'm noticing that the right-hand side of this polynomial is down. All right? The right end behavior is negative infinity. That means a negative leading coefficient. So that tells us that the answer cannot be B. All right, so we're down to either C or D. We can choose that based on the behavior of the graph at this middle 0. So notice that the graph just passes smoothly right through 0. So that means it has to be a multiplicity of 1. If it were multiplicity 2, I would see a bounce. It would be tangent to the x-axis here. All right, it has to be multiplicity 1. So the answer must be C. Number 12 is similar. The graph of the polynomial function f is shown above. Which of the following could be the equation for f? So we can tell that this graph has a positive leading coefficient because the end behavior on the right is positive infinity. So based on that alone, we can eliminate C. F of x only has two real zeros. There's one at -2 and there's one at +3. Based on that, we should see factors of x plus 2, which would give us the real zero of -2. And we should see a factor of x minus 3, which would give us the real zero of 3. There shouldn't be any other real zeros. So looking at option D, I see my x plus 2 factor, and I see my x minus 3 factor. But I also see this other guy. Well, that could be, that's okay. This could be imaginary. This would be imaginary. So I'm not eliminating D. Let's see. X plus 2, x minus 3, A is still possible for a moment. I'm going to eliminate B now, because this has x minus 2 and x plus 3. That's wrong. Those would give us the wrong zeros. So we've narrowed it down to either A or D. So now let's use the multiplicity to make the final choice. At the zero of -2, I see this bounce. I see how it is tangent to the x-axis at -2. That means multiplicity of 2. So the x plus 2 factor should be squared. Same thing with the x minus 3 factor. This should be squared because this bounce indicates a multiplicity of 2. Looking at option A, neither of these are squared. These are both multiplicity 1. The graph would just pass straight through those zeros if A was the answer. So the answer has to be D by this process of elimination. All right, both of these are squared and we're good. The remaining zeros that are coming from this are imaginary, so they're not going to show up on the graph. Number 13, solve the following inequalities. So the first step of solving inequalities is to list off your zeros. So I'm seeing that f of x is going to equal 0 at x equals -4, x equals +3, and x equals -1. Next, we make a sign chart. Always label your sign chart. So we're going to label this as f of x. I've made a row for every factor. So I have a row for the x plus 4, and a row for the x minus 3, and a row for the x plus 1. I've made a little vertical line for every 0. These need to be written in order from least to greatest because this is really a number line across the top. So we have to start with -4, and then -1, and then 3. So now it's time to decide whether these factors are positive or negative in each interval. The x plus 4 factor gave us the 0 of -4. So this is the only place where this might change signs. So I'm going to think to myself, x plus 4 is going to be negative to the left of -4 and positive to the right, which is typical. The factor of x minus 3 gave us the 0 of 3. Focus on that. It's going to be negative to the left and positive to the right. The x plus 1 gave us the 0 of -1. It's going to be negative to the left of that and positive to the right. I need to know the overall sign of f of x. That's what the top row is for. And really I'm just counting the minuses. If I see an odd number of negatives, I know it's going to be negative. If I see an even number of negatives, f of x will be positive, because a negative times a negative is a positive. Alright, that single negative means f of x will be negative in that interval. All positives, f of x will be positive. So now I need to decide which intervals I'm actually interested in. We are looking for the values of x that will cause this polynomial to be greater than or equal to 0. So the solutions will be in the intervals where f of x is positive, greater than 0. Because it says greater than or equal to 0, I'm going to include the zeros themselves. And I just highlight them to remind me to do that. These zeros are where f of x is equal to 0. So they're going to be included in the solution. And I'm going to show that with brackets when I write the solution right now. So we have the interval from -4 to -1, including -4 and -1. So we're going to use brackets. And then we'll say union. And then it's 3 to infinity. Again with the bracket to include the 3. If this had just been a greater than problem and not a greater than or equal to problem, I would have used parentheses everywhere. Let's do the same thing for number 14. Let's start off with making a little list. And I would really like you to label the way I'm doing. Next year in calculus, we do this all the time. And the labeling of our work is super important. So I really encourage you to write f of x equals 0 with a little line under it and copy me. So the zeros are going to be x equals -2, x equals +1, and x equals +5. The -3 in front, that's not going to give us a 0. So time for the sign chart. This time I've made 4 rows on my sign chart. I made a row for every factor. Notice I'm including the -3. Even though the -3 did not give us any zeros, I still want it on the sign chart. So make a row for that -3. And then I have a little vertical line for each one of the zeros, and here I've put them in order from least to greatest as a number line. So when it comes time to decide if these factors are positive or negative in each interval, of course the -3 is always negative. So for that constant, you're just going to put negative all the way across. If this was +3, it would have been pluses. The x plus 2 gave us a 0 of -2. It's going to be negative to the left, positive to the right. The x minus 1 gave us the 1. It's going to be negative to the left, positive to the right. The x minus 5 gave us the 5. Negative to the left, positive to the right. Look at all those minuses. That's an even number of minuses. F of x will be positive in the first interval. The odd number of minuses means negative in the next interval, and then positive in the third interval, negative in the fourth interval. We are looking for the values of x that will cause f of x to be less than 0. So the solutions will be wherever f of x is negative. That's here and here. Notice that it's less than 0, not less than or equal to. So we will not be including the endpoints. We will not be including the zeros in the solutions. We will show that the zeros are not included by using parentheses for the endpoints. So this first interval is from -2 to 1 with parentheses, union, and then that last interval goes from 5 to infinity. Find all real zeros and indicate the multiplicity of each zero. We've got x equals 3, multiplicity 4, x equals -2, multiplicity 1, and x equals 1, multiplicity 1. Number 16, a monomial with an x in it is always going to give you x equals 0. It's just a plain x, so that's multiplicity 1. x equals -3, multiplicity 1, and x equals 2, multiplicity 3. Number 17, this monomial again will give us x equals 0, and it has a multiplicity 3. You see the exponent. This factor gives us x equals -7, multiplicity 2. And this factor gives us x equals 3, multiplicity 1. For number 18, we have some factoring to do. So we have y equals -2x. X squared minus 4 factors as x plus 2 times x minus 2. Now what about this trinomial right here? This is surely going to factor as a binomial times a binomial. So x squared will factor as x times x. 4 is either going to factor as 2 times 2, or it could be 4 times 1. But looking at the middle, let's go with 2 times 2. And since the middle term is -4, that's going to take a -2 and another -2. Also notice that -2 times -2 does give us the positive 4 on the end. So we factored it. Now let's look at the next trinomial, which again will surely factor as a binomial times a binomial. Okay, so again, x squared is going to factor as x times x. 8. 8 is either going to factor as 2 times 4 or 1 times 8. The middle term is -2x. So let's try 2 times 4. Sometimes I say inner plus outer equals middle. So inner I have 2x, outer I have 4x. I'm shooting for a middle of -2x. So I need a positive 2x and a -4x to make -2x. That means I need a positive here and a negative here. The factor of x plus 2 appears twice. So I could write this as x plus 2 squared. The factor of x minus 2 appears 3 times. So that's x minus 2 to the third power. And then we have an x minus 4. The first factor gives us x equals 0, multiplicity 1. The second factor gives us x equals -2, multiplicity 2. This factor gives us x equals 2 with a multiplicity of 3. And the last factor gives us x equals 4, multiplicity 1. Number 19, the polynomial function f has n behavior described above. Which of the following functions could be f of x? So let's start with the right n behavior. The fact that the right n behavior is -infinity tells us that we have a negative leading coefficient. So that eliminates option A and B. The fact that the left and right n behavior are the same tells us that we have an even degree. So that means the answer has to be C. Same directions for number 20. Always start with the right n behavior, the limit as x approaches positive infinity. The fact that the right n behavior is -infinity means that we have a negative leading coefficient. So that's going to eliminate A and B. Now look at the left n behavior. The fact that this n behavior is the opposite of the right tells us that we have an odd degree. So the answer must be D. Number 21. Looking at the right n behavior, the fact that it is approaching positive infinity tells us that we have a positive leading coefficient. So that means we can eliminate option A and option C. The fact that the left n behavior is the opposite of the right tells us that we have odd degree. We can find the leading term of B by looking only at the leading term of each factor. In other words, 2x times x to the second times x to the fifth. That gives us 2x to the eighth. That's an even degree. We are looking for an odd degree. So b cannot be the answer. Similarly, the leading term of d can be given by this, which simplifies down to 2x to the ninth power. That is the odd degree we were looking for, so the answer is D. For number 22, we need to match the correct left and right end behavior with the given polynomial. This polynomial is not written in standard form, so be careful to look at the negative 7x to the fourth power as the leading term, not 4x. And because our leading coefficient is negative, that tells us that the right end behavior is negative. So we can eliminate options B and D immediately. K of x has degree 4. The fact that this is an even degree tells us that the left end behavior will be the same as the right end behavior. So negative infinity. So that means that the answer must be A. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.